we're going to perform another forward and backward scan on this particular network to establish the critical path and the earliest and latest start time of all of these particular tasks in the project. Alright, so remember, the technique I like to use first of all is to highlight all the instances where I've got multiple edges or multiple tasks leading into a vertex. And that just reminds me that there's a couple of pieces of information to consider before writing a number as the EST into those boxes. Alright, so there's all the instances of that happening. Right, now let's draw up those boxes. So 2 boxes for this vertex, 1 for A and 1 for B. 1 box for C, 1 box for D, a box for F and a box for E, 1 for G, 1 for I, 1 for H, and 1 for the finish. Alright, now let's commence the forward scan. Alright, so A and B can start concurrently and have no predecessors, so their EST will be 0. Alright, let's do C. C will only depends on A, so we've got 0 plus 9 is 9. Alright, let's do D down here. Now D has 2 predecessors. Now this is a dummy task here. Now let's go back and see where it comes from. It comes from here, so we go backwards along there and back down here. It actually originates from A. So I've seen a lot of times they denote that as A0, means it's originating from A, has task duration of 0. So I've got a potential 9 coming from A, or I've got 0 plus 7, 7 coming from B. Now you'll remember what we do is we put the largest number in the box. So the earliest start time of D is 9. Alright, G has a couple of considerations. We need to consider either 9 plus 8, which is 17 from D, or E. Now we haven't got that yet. That'll be easy to get. 9 plus 11 is 20, and that can go straight in because there's no other information to consider. Now we can go 20 for E plus 10, 30 from E. Now which number goes in the box? It's the largest number. Alright, now I've got for F 20 plus 11. Earlier start time for H will be 20 plus, where are we? 20 plus 11 is 31. Alright, 31 plus 9 is a potential 40 from H, or it's 38, 30 plus 8, 38 from G. 40, largest number goes in the box. 40 plus 6, 46. Alright, now let's go to the back scan. 46, 46 take 6 is 40. 40 take away 9 is 31. 40 take away 8 is 32. Alright, now 31 take away 11 is 20. Down here, 32 take away 10 is 22. Alright, over to here, 32 take away 8 is 32, 30, 24. 20 take away 11, or 22 take away 11. Now which one do we do? Now remember, we've got 2 instances there over the vertex, and it will actually be the lowest number. 20 take away 11 is 9. Alright, down here we've got 9 take away 9 is 0. Down here we've got 24 And what are we going to do? We've got 24 take away 7 is 17. Okay, so let's have a look here. Now, first identifying the critical path. Let's go through and grab a highlighter. And we've got 0 and 0 there, which means that is on the critical path. Alright, now, then we go along C, then we go along F, then we go along H, then we go along I. Alright, so there's my critical path. So the critical path, if I write it, will be A to C to F to H to I. So that's our critical path. Now the numbers should add up. 9 plus 11 is 20, 31, 40, 46. That equals 46. So there's another version of a path analysis problem where we got a dummy connector in there.